This is higher homework. It's practice paper A that we're looking at today. We've got question 3 from the calculator paper, and we'll go ahead and do that now. Okay, so what we've got to do is to find the equation of the tangent to the parabola with equation y is equal to 6 plus x minus x squared. Okay, so we've got a parabola that's sitting here in the diagram, and what we're looking to do is find the equation of this straight line here. Right, so when I see a question like this here, I know that what I've got to do to get the equation of the line, I need the gradient, and I need a point on the line, and then I can substitute it into the equation of a straight line to get the equation of this particular line. So first of all, what we'll do is we'll try and work out the gradient. And when I work out the gradient, what I'm going to be thinking about is differentiating. So let's go for part A first of all. Okay, so I'll write down the equation first of all, and we'll get a start with that. Okay, so if I differentiate, I'll find dy by dx. And remember, dy by dx is just the same as working out the gradient. So this is a gradient formula that I'm going to work out here. 6 differentiated goes to 0, that'll give me 1, that'll give me minus 2x. So that's differentiated. And that would be the gradient formula. So for any value of x that I know, I can find out what the gradient is at that point. Now the point that I'm given is the point 1, 6. So what I'll do is I'll use the x coordinate from that one to substitute in there and try and find out what the gradient of the line is. Okay, so what we'll be using is the point 1, and it's the x coordinate I'm using from the point, and that's going to be 1 minus 2 times 1, and from there I get an answer out there of minus 1. So the gradient of this line is negative 1. What I'll do then is I know a point and I know the gradient, so I'll just substitute the gradient equal to minus 1 and the point is going to be 1, 6 into the equation of a straight line. So that'll be y minus b equals mx minus a. Right, so remember that's my a value, that's my b value. So let's go ahead and substitute them in. So y minus 6 is equal to gradient of minus 1x minus, and I've got a 1 that's up at the top there. Okay, so that would be the equation of the line. So what I'm going to do next is I'm going to look at part B. Okay, and for part B, what we've got is we're going to show that this line is also a tangent to the circle with equation, here we go there. Okay, so when I'm going to try and show that, what I'm going to be looking to do is to do a kind of simultaneous equations piece of work. And what I'll do is I'll substitute in either an x equals or a y equals, and what I'll get from there is I'll be able to get something that I can either factorise and work out a point. Right, so I have to show the line as a tangent, so let's go ahead and do that. What I'm going to do here is I'm going to sort this equation out and just simplify it a bit so I can substitute it into the circle equation. Okay, multiplying out on the right hand side, I'll get minus x, and that will be plus 1 over there. I'll gather it all together, and what that gives me is y is equal to minus x, bringing the 6 over, that will give me plus 7, and that would probably do. What I'll do is I'm just going to tidy that up a bit just to help me out. So that's going to be 7 minus x, and that'll be a wee bit easier for me to simplify in there. So I'm going to simplify in where I see y in the circle equation. So I'm going to substitute y is equal to 7 minus x, which is the equation of the straight line that should be a tangent to the circle, and I'm just going to substitute that into the circle. Okay, here we go. So from up above, what I've got is, let me just kind of blank this out a wee bit. Right, so I'll go with, I've got x squared, I'm going to plus y squared, so instead of y, I'm going to be substituting in 7 minus x, and I'm going to square that. I've got minus 4x, I've got minus 14 times the y that I'm going to substitute in, so that would be 7 minus x, and I've got plus 51, and that all equals 0. Right, so let's square that bracket, multiply that bracket out just now, okay? So I've got x squared, I've got plus 49 minus 14x, that will be a plus x squared. I've got minus 4x sitting there, minus 14 times 7 will give me a minus 98. And I'll multiply the minus 14 by minus x, and that will give me a plus 14x. and they're just sitting on the end as that plus 51. Right then, so if I look along the line what I've got, I can see a plus 14 here, so I could take that out and take that out, so they'll cancel each other out. All I'm looking to do is just gather everything I can. So I've got x squared there, and I've got an x squared there, so that gives me 2x squared. I'll look at the x's that I've got left, so in the x's there should give me minus 4x, okay, because these two here are going to cancel out, and there's the minus 4x I've got there. And from a number point of view, when I gather all the numbers, what I should be left with is just 2, and that equals 0. Right then, so what I'll do is, just to simplify that out, I'm just going to divide everything there by 2. So if I divide that by 2, it just simplifies things down for me. Okay, that goes to there. So in here, what I can see is that my a value is going to be equal to 1, b value equal minus 2, and the c value is equal to 1. And what I'm going to do is, I'm going to do this in 2 different ways, okay, to show that the line is a tangent. So what I'll use is b squared minus 4ac first of all, so that will be the discriminant. Okay, so b squared minus 4ac, let's see what that equals. So I'll substitute in minus 2 squared, and it's going to be minus 4 times 1 times the value of c. And that's 1 there as well. So what I can see here is that equals, I'll just put in equals 0 there. So since the b squared minus 4ac equals 0, this is just a statement that I'm making, there are equal roots. There are equal roots, and therefore I'll just say that therefore tangent A exists between the line, I'll just say it's y is equal to 7 minus x, and I'll just say the circle. Okay, so what I've done is I've shown that it's a tangent through the discriminant. The other way that I'll do it, maybe you've done it this way, is just show that there's one point of contact. So what I'll do is I'll factorise this part here. So all I'm doing is taking that down to there, and I'm just going to work that through. So if I factorise that, so I'll put it into 2 brackets. So I've got x there and x there, 1 and 1, both signs are positive or both minus, so they're both minuses that are here. So what I can see is x minus 1 squared, 2 of them there multiplied together, equals 0. So from there I can see that I've got x minus 1 equals 0, so x equals 1. Okay, so that's looking like one point of contact. I'll just work out the y value there as well by substituting it into the equation. So y is equal to 7 minus x, which then equals 7 minus 1, so which equals 6. So the point of contact is just 1, 6. So it's the same point. It's the same point as here, just probably by coincidence, but it doesn't have to be that. Okay. Right then, so what I'll do is make a statement here. So since there is only one point of contact, and I'll just put the coordinates in there, that'll be 1, 6. I'll just say the line is a tangent to the circle. Okay, so that's the 2 ways that I could do it. Okay, so that would work out pretty well for me there. Let's see how we'll go ahead and mark this one. Let's go for, let's see, first mark would be for straight differentiating, that one there. Next mark would be for getting the gradient. Third mark for getting the equation of the straight line, which is that one there. And what I'll do is for part B, I'll give 1 mark for rearranging it into a form where we can substitute it into the circle. I'll get 1 mark for substituting it in, okay, for knowing to substitute it. 1 mark for getting a form where I can factorise with an equals 0 on it, so that would have to be there. Next one would be for working out the discriminant here, so that would be for getting that equal to 0, and then finally a mark for that statement. Okay, so that'd be 1, 2, 3, 4, 5, 6, 7. Is that 8 I've got there? Let's have a quick look what I want to do there. So it's a 9-mark question, so let's look again. 1, 2, 3. I should have 4 marks for the first part. Let's see. Right, okay, so what I'm going to do here is I'm going to give 1 mark here for knowing to differentiate first. So there's 1 mark coming in there, okay? Knowing to differentiate, so if I can see dy by dx somewhere, that'll be one thing. Differentiating it correctly, that'll be the 2nd mark. Then the 3rd, 4th, 5th, 6th, 7th, 8th and 9th. So that's the marks that I'm going to give for this question here. If, on the other hand, you go down the other route, what we'll do is we'll get 1 mark for showing that there's only 1 point of contact, and the mark there for getting the statement correct based on that there. Okay, so that's question 3, paper A and the calculator paper.